Speak up.
So what I thought of was another way to simulate the feeling of zero gravity without using a plane or training astronauts underwater. So what this does is, I don't actually have a physical explanation with me currently, so I used this program to just kind of draw out my explanation. How we can simulate gravity currently is we have a plane and it goes up and down, and when it goes down, the g-force is then negative, making about the same amount of gravitational force as the moon. Now the problem with that is planes use fuel, cause pollution, and it's not completely effective, and when the plane has to come up to avoid crashing, then it creates a positive g-force, which can be painful if you're not ready for it. And we also train astronauts in pools, and water is actually very dense, and so it's kind of slower than in air. So here's an example of how water can crush a can if it's at the right sea level, and obviously you don't want to crash on the bottom. So what if we could have a constant stimulation of zero gravity without planes or pools? And what if we could train them with levitation, or rather quantum levitation? Quantum mechanics allows this to happen with quantum traveling. With quantum levitation, we can simulate the feeling of zero gravity. We start with a superconductor, a bit of liquid nitrogen, and a magnet. What happens is when we put the magnet into liquid nitrogen, it cools it down so that quantum flux tubes are trapped, allowing the superconductor to levitate. Now, the superconductor won't go anywhere with a single magnet. It's locked in place, but you can position it however you want. But if we do make a rail of magnets, we can push the superconductor and it will glide with only air friction slowing it down. This basically shows that we can simulate zero gravity in a way. If we lay a whole floor out with magnets, could be electromagnets, to give a powerful magnetic field, and we give a guy a suit that has a bunch of little superconductors in it, then possibly simulate zero gravity and the feeling of maneuvering through the space station, and possibly EVA training. So I have a video from YouTube that kind of demonstrates this. Display. As you can see here, the superconductor glides above the rail without touching it effortlessly.
Wow.
With these magnets, it flies about 40 millimeters above the track, but if we use stronger magnets, we could cause this to go even higher. And we also can add multiple superconductors, and they would pass over and under one another effortlessly. If I had a physical object right now, I would show you, but I don't think my parents would allow me to play with nitrogen. And this shows how you can use the same exact method and have it hover when the magnets are above it. So it could be on the ceiling, it could be on the walls, anywhere. And as I said before, with electromagnets, we can have it off, and then when they walk in, turn on a switch, they start to levitate. So they can push off walls and just fly around as if they were in space. And obviously, this creates no This needs no fuel or there's no fuel, no need to do a wave-like motion in the air, and no water. So energy efficient, cheap, and easy.
Nice. Also, one of our younger members. Good job.
You know, if you volunteer at the Franklin Institute, they have plenty of liquid nitrogen you can play with.